Without further ado, let's invite our next speaker, Anuj Mehta. He's a senior staff software engineer and loves the 0 to 1 stage of building. His talk today is about from code to craft, software engineering principles for Python programmers. Let's make some noise for him.
Hello. Hi. Hi, everyone. To be very honest, I didn't expect a full house, and this is kind of making me a bit nervous. There's so many people here. The whole talk is kind of based on, all the work I've been doing over the few years, and it could be slightly opinionated, so please call it out, find me after the talk, and, get into a healthy debate if you'd like. But I'm kind of always open to suggestions. I know there are a lot of engineers from different levels and years of experience, and I'd love to hear your opinions after the talk. You can heckle me a little, but not too much, okay? All right, so a little bit about myself. I have spent a lot of time, I wrote my first Python code about 10, 12 years ago when I came across a book called Head First Python. I still love that book. Anyone who asks me any tips about coding, I just give them that book. Even though ChatGPT and YouTube is here, I still just go for that. I have kind of had an interesting career trajectory. I started by crunching data, building models, then loved the engineering phase of it, and then kind of got into software engineering. I think there have been a lot of ups and downs. I've learned, I've seen both sides of the table. When I used to be a Python programmer, I just learned Python. I write scripts that work, right? But before I get into what went wrong, I want to tell you a little bit about myself. As I said, I spent some time modeling. I spent some time crunching data. I used to love web scraping. Fun fact, 7 years ago, I gave a talk in PyCon India. And that was kind of my first talk, and it's very, I was very happy when Bhavin informed me that I get to present again. It's kind of a slightly nostalgic moment as well. And I was very happy when I got in. I did a lot of web scraping, and I only submitted a proposal back then, and I hadn't finished doing it, right? And when they told me that I got in, I was like, oh, well, I have to execute this now, right? I have to actually do this. But this time I had it more prepared, but it was very fun. It was a lot of fun. And for people sitting here, I would really encourage you to kind of submit a talk next time. I think a lot of us hold back on putting in a proposal because hey, I don't think this will get in and stuff like that, but forget about it. I'd really encourage you to kind of try submitting a talk next year. Not just PyCon India, there are a bunch of conferences. Start small if you like, PyData Bangalore, etc. But yeah, as you can see, I lead the product engineering team at a small startup called Game Theory. If some of you have played at some of our facilities, great. Give me a cheer after the conference. But yeah, find me if you think the company is interesting. But I want to start getting into the more fundamentals. I tried to structure the talk in the way I kind of learned it. Like, do I really need to learn this? And what is going wrong with my code? Okay, how do I fix it? And okay, now I fixed it, what will happen to my code, right? The talk is most useful for people who identify with any of these. So let's say if you started writing code, this is basically a time when everyone is empowered to build applications, to build things that you like, write all kinds of code you want. If you want to build a machine learning algorithm or a machine learning model, you're free to do now with the advent of ChatGPT, LLMs, etc., right? But regardless of that, when you get some code from ChatGPT, you see it's kind of well structured, well defined. You see the code, and you understand most of the things, right? But as you start adding stuff to the code, as you start making modifications to the code base, how is it changing, right? So if you notice, I think there are a couple of slightly debatable points here. I think the last one is the one I've been called out on most. No comments on the code is writing inline comments on the code kind of feels that the code is not good. Well, this was one of my colleagues. We used to ship a lot of TypeScript, and he kind of just said something that was quite intriguing. He said, if the code has comments, it means it's not well say defined or structured. What we mean there, this doesn't apply everywhere. This doesn't apply to open source contributions because there are different types of engineers, programmers, all sorts of people trying to contribute to a code base, right? When the company gets that big, when the team of collaborators, number of people working on that code base gets really big, then yes, you need a lot of documentation, comments, everything an engineer can get, right? As much help as possible. But initially, when you're structuring your code base, we'll talk about some of the principles or some of the sections coming in, and maybe at the end of after you see all the 4 or 5 sections, you'll probably understand why not having comments in the code is probably not a bad practice, right? So yeah, I'm not going to read out text from the slides, but this is kind of hey, you are new to engineering, or you're new to programming, you're writing code, it works. Now, how do I take it to the next level? Now it works, and just like I showed it to someone on my computer, they were super excited. They think this can be a potential company. What do I do from there, right? Well, you can take all of that code and ship it. It works, but when will it break, right? So, funny story. The first time I deployed an application, I SSH'd into a server and typed run python.py. I think it was a Flask application, and I said it was deployed. I did not know that when 2 people access the website concurrently, sometimes it may break. And I did a whole public launch, it failed. That is when I learned what DevOps is, right? And it's been a very long time, and I still kind of enjoy breaking my code from time to time, right? So let's get into some of these principles. And what I would love for you to think about is all of this will not apply to everyone. Maybe some parts of this will apply to some people. Maybe all of this is very intuitive and obvious to a lot of you, which will be great. But my only hope is you probably see something that catches your eye and you take it and you kind of maybe slowly improve on top of it, right? So the first thing, I forgot to tell you why this is important. So this is exactly how I was as an engineer. I would write functions that were insanely long. And if a Python function is, I don't know, like 100 lines long, it means it's doing a lot of things. In my opinion, a function or a piece of code or a unit of code, it could be a function, it could be a loop, it should do one thing that it's designated to do. If it's doing multiple things, it gets difficult to test it. It gets difficult to entangle. And if it's doing multiple things, it means most likely in the future, there'll be multiple people working on the same function. Right? If you're used to GitHub, you know how bad merge conflicts can be. And they have led to fights in companies. Okay. So they'll be like, hey, I pushed my code, now you have to resolve your merge conflict. Right? I'm like, no, I raised the PR first, but I merged it first. Right? And all of this will happen, and this is based on real life experiences. And a lot of times I had to get on a call with the other engineer to explain how the code works. And it was good, right? It gave me a lot of confidence, but it also kind of meant that you become a dependency. You cannot take more holidays. Someone's working on your code base, they'll give you a call and say, hey man, I know you're sitting on the beach, but how does this function work? Right? You don't want that. The last one is, I think, the most important one if you're shipping to production, right? You write a piece of code to add 2 numbers, and you think it'll most likely work. What if someone sends a letter or a string instead of a number to the function? Are you checking if it's a number in the function? If not, it launches on production and it may break, right? So you need to be kind of careful. We'll again get into all of these things in a bit. So the first part of this, what you can do is code reusability and modularization. I think it's the amount of planning required when you're writing a code base or when you're building a big chunk of code base is underestimated. A lot of us just dive into it. We're like, okay, let's start working on it, right? I know, I need to add two numbers and I need to multiply two numbers. That's all, right? Let's start. But you never asked if it's going to be a string. Is it going to be, I don't know, a number, a one, just one number inside an array, right? So you need to ask a lot of clarifying questions. You need to plan it out better. Why? Because when you start breaking a bigger problem down into smaller problems, that is where it's most useful, right? I was actually talking to someone outside, and we kind of agreed that the way you go from a junior or an entry level engineer to a senior engineer is your ability to break complex problems down into small units of code, right? You have a very complex. Let's say I say, hey, let's build a booking module, right? And what do we have in the booking module? How do you break it down to small pieces where an engineer can pick it up and just start working, right? That's the beauty of kind of planning your code. A lot of the small things here, for example, abstractions. Go to any of your code bases, right? See if you've ever declared a string inside the code, right? It's like, hey, if x is equal to, I don't know, like some key or some URL, or I think a lot of us would have defined URLs inside a function, right? We refer to those as magic strings, right? You cannot declare magic strings inside a function because one of these days that URL is going to change. And when that URL is going to change, you do a global search on your code base and replace that URL. Unnecessary. Abstract it away, store it in a config file, you're golden, right? And if you start getting into how code bases are deployed, etc., config files are easy to update versus deploying a code base, right? If you tell someone that, hey, I need to make a deployment, like, why? Actually, the service, the API we are using has updated their URL structure, so we have to redeploy our entire production stack. No way. Compared to, hey, we just need to refresh our config. Sure, why not? Right? The gist here is to try and plan your code in a way that it's more reusable, or parts of it are more reusable. Simple, and this applies to all sizes of code bases. Are you starting a new project? Sure. Plan a little bit. It doesn't have to, you don't have to spend 3 days planning on a code base that takes you 2 hours to write. Spend 15 minutes, sketch it out, right? So actually, there is a third option. Talk to ChatGPT about it, right? Say, hey, I'm building a booking model. Can you break it down for me? And it'll help you design it really well. Actually ask it. Say, hey, I want to make sure my modules or my pieces of code are more reusable, right? It'll tell you how you can do it. So this is the help maybe people didn't have 5 years ago. You would have to ask another engineer, but now you get to, right? Last thing before I go to the next slide is naming conventions. If I ever see a I in a for loop, define I, start getting the GPs. Like, oh, why is it a I? I know it's a counter, but sure, call it a counter, right? So although when we start writing code, it feels very silly to kind of update it. And if you're in an interview, of course, I mean, if you write an I, it's acceptable. But if you write a counter, I think you can sometimes get brownie points, right? But just naming them whatever they are. You're saying you have 5 for loops, and if you have 5 I's redeclared again and again, it gets messy, right? So try and just add simple naming conventions. Again, functions, modules, classes, all of these. Ask ChatGPT, hey, I'm building a module that is this, and this. Give me a good name. It'll give you the best name, right? You don't have to read books. You don't have to refer to blogs to see what a good naming convention for this has to be, right? So also, can you just highlight or just read the boosts thing that you have on each slide? This just calls out what this helps with, right? A lot of this has to do with, if you break it down into usable components, when you're collaborating, when your team size is growing from like 2 engineers to 15 engineers, the dependency graph changes a lot. Every engineer will look at the code base. They're like, okay, I know this function, it says add 2 numbers or add 2 integers, right? Like, okay, fair, I'm just adding 2 integers. I look at the code, makes sense. Instead of calling a function add bracket a comma b. Why? You can say number 1, number 2, maybe, just better, right? Or take a numbers array. Just planning all of these things help. Next, I think when I was writing a lot of scraping, when I was doing a lot of scraping, my go-to was no functions, no classes, just write code. Jupyter Notebook, open cell, and I wouldn't even break it down into multiple cells. In a single cell, I write all my code, right? Then I kind of learned the concept of using a Jupyter Notebook, and I kind of break it down. But even then, right, we will start writing scripts, with, again, the urge to quickly write code. It's great if you're able to break your notebook down into logical pieces, great. But if you give it to someone else, if you want to like export it, deploy it into production, you'll have to again try and maybe make it a little more maintainable, right? So this is great for experimentation. I don't want you to write an object or a class, the functions and everything if you're trying to see if you can scrape a website. But once you decide that, once you've decided that you can, maybe try and adopt this. And this actually changes a lot, because if you don't adopt it early on, it's going to be a big hassle to go back and update all of your code base. So all of these steps are baby steps. Just think about it when you're starting a new project. Or if you have an existing project, any new functionality that you're adding to it can follow some of these principles, right? And I think I learned the importance of using some of these design patterns. And behavioral design patterns, I think there's a website, if you just search for behavioral design patterns, it shows up. It is so like nicely illustrated, like that, right? It's just clear, very nice, graphics and everything. I loved reading those. And recently I was trying to write a piece of code, and I asked ChatGPT, he said, hey, can you use some behavioral design patterns for this? It gladly did. So it's so easy for you to kind of ask that, hey, this is my use case. Can I use any design patterns? So what happens with that is, it becomes like, these are complex things. So let's say if you're building an invoicing or I think taxation is what I was building. Now, taxation works in different countries in different ways, different states in different ways. If you're selling in the same state, it's different. If you're selling across your border, it's different, right? Which means there are different types of things you need to do. So you can pick a design pattern for that. And this is just a logically complex problem for you to solve. So design patterns usually help you break it down faster, right? Again, there are a lot of principles and all of these, and all of this apply at, for all the industries. If you're a ML engineer building a model for a biotech company versus you're a freelancer building code for someone, all of these just make it easier for people to understand how you're thinking, right? You ship a code base, you give someone a GitHub repo, they'll see, okay, this is a class, okay, this is the functionality of all of this, makes sense, I'm sold, right? The next thing, and this is quite an important thing, exception handling. If you have one try except in the entire code base, no, not acceptable. At least call out exceptions, right? You have to handle different exceptions separately. You cannot say try 4,000 lines of code except print the error, right? You'll find yourself debugging that for a very long time. So if you're someone who does that, and I'm not kind of, calling people out and, attacking people for just using one try except, but start adding or catching exceptions. You say, hey, let me catch a, divide by 0 exception, right? And then as you kind of see more and more errors coming up in your except part of the code, you can start handling these exceptions better. Try and, again, if you follow the first one where you're dividing your code base into nice logical pieces and you add one try except with good exception handling, you're sorted. Because when you start debugging, you say, okay, it seems like this broke here, so this is okay, all right, I think this is this 7-line function that I need to repair. Versus your 4,000 lines, you will add 300 print statements in that 4,000 lines, and the print statements are also not good. They're like printing 1, printing from line 3, and I do that, at least if you don't. So you can kind of skip through all of those basically. Okay, yeah, great logging. There's a company who is focused on observability, right? So when companies like that don't exist, we used to depend a lot on logging. We send good log messages, and we still do, right? We search them and so on. But it's important to understand how your code is handling exceptions. I kind of learned the importance of try except in a very different example. So you remember we used to have these digital cameras, right? So there was a battery inside this digital camera, and it wasn't shaped like a rectangle. It was oddly shaped, and I was curious why. The reason it was oddly shaped is because you cannot fit the battery in any other way. There's only one way it goes in, which means they are taking out all these exceptions away from a product just using a good product design, right? So your code has to be like that. You're able to handle everything that can go wrong, or you know everything that can go wrong with your code. That's the importance of exception handling in real life and in code bases. Last and my favorite, testing. How many of you here have written a unit test or any kind of test? Okay, I don't think I can. We can probably skip over this slide in that case. But if you've tried the challenge here, I was watching people play. It says you have to kind of, I think, pass 10 tests or 7, depending on the problem you get. It was difficult, right? Even ChatGPT couldn't do it. I mean, sure, testing is a more, it's been kind of standardized pretty well now, and you know a lot about testing. But there are different types of tests. There are integration tests. There are unit tests. If you're a front-end developer, you're a back-end developer. All kinds of things come in. And especially if you're working for a company that is just trying things, building things, you're in the 0 to 1 phase, you skip over testing, right? You say, yeah, test is just I know this code will work, right? This is what they're paying me for, and we'll ship it to production. We'll see if it breaks. Spoiler alert, it does. It does break, right? But if you're able to write good unit tests, it also helps you when you're releasing new features. How do you know that you're not breaking an old feature by releasing a new feature? That's what someone did at the booth, right? They were solving for 3 more tests, but they broke 3 tests that they already solved for. So I think that kind of helps, and especially if you've broken your module and your functionality down into smaller pieces, you make all of them testable. If it's a utils file, if there's a function that that's very logical, it's just doing math calculations, you can write a bunch of tests around it, right? What if this is 0? What if this is a empty string, and so on? This will just help you catch errors and things that can potentially go wrong later early on, right? And this, I think, also applies to data scientists, people who are scraping, building. I think it comes in all shapes and sizes. I'm not the expert, but I have been up till 2, 3 a.m. in the night because of this. And when we were also building, we had already built a lot of code. So we kind of decided to just say that, hey, we won't go back and add tests to all of our code. The new code we start writing will only add tests to that. That's all. That increased our code coverage gradually. 0, 3%, 5%. Sorry, and we ended up going up to like 60, 70%, which is super healthy, right? So maybe that can be a potential action item. Tooling and automation, I think I'd like to skip over this in the interest of time, but this mostly talks about processes that you can set up that will save you a lot of time. If you go, again, right, as I did, if you SSH into a machine, do a git pull, and beyond build and all of that, or if you're building and deploying it using terminal, time can be saved. But if you're the only one doing it, if you're releasing once every 2 weeks, then sure, you can skip over this. But if you're adding collaborators, if your team is growing, it's great to add some tooling and automation. Simple, CI/CD, Slack bots, all kinds of things, right? Okay, so we did, we made all of these corrections. Sorry, we made all of these corrections, and how did that help the company, right? We saw insane results. Like all of these numbers were through the charts. The efficiency, productivity per developer. Well, that is not how the world works, right? You cannot make all of these changes overnight. These are very gradual changes. You may get frustrated. You're like, hey, I've been writing tests like Anuj said. My productivity is not improving. Well, a month later, you might have been called into a production fix when you were watching a movie at 12. You would say, hey, I know I wrote these tests. Let me just fix it for you. Versus, walk out of the movie, go home, find out it was one character that messed up the code, right? Also, I mean, when I made this, it was like 300-400 NVIDIA, and now it's like 7x or something. So, yeah, so these are gradual changes. These take time to kind of reflect. Even in our organization, and these are very difficult to implement. If you're already running, if your code base is already quite big, 4 or 5 collaborators, super difficult to implement them. but this will only get worse. As time goes on, it'll just get messier and messier, right? So might as well try and take baby steps. These are some baby steps I was able to list out. But existing code bases, as I said, you're not writing any tests. You don't have any testing library at all. Start with some. Just start writing tests, gamify it. If you're using GitHub, right, you can set up a lot of GitHub actions that kind of show leaderboards, reward your engineers. You say, hey, you know what, whoever is the last, the last person on the leaderboard buys drinks for everyone after the week or after the sprint, and so on, right? What we're doing is, if someone breaks production, they do like 5 push-ups or 10 in the office, right? Not take a video of it and but yeah, and brownie points if someone notices the Thanos reference, a subtle Thanos reference at the end. But yeah, take small steps, try and improve your code base as much as you can gradually. Thank you. Yeah, so this talk is more from my experiences as I was going from someone who just writes code that works to someone who's shipping code and stuff. I've been bashed a lot. I was doing a lot of debugging, and this is kind of just a reflection of sorts. A lot of things, I don't know if they were useful, if they were not, but let's all try and adopt these things. Let's not try and reinvent the wheel, and let's try and make all of our code bases nicer. Thank you. If you have any questions, I've been told you can come there and ask them. Or if anyone wants to call me out on no comments on code base remark, they're welcome to.
It might be a little difficult to move around with so we have volunteers who will pass the mic. Just raise your hand and yeah, we'll pass around the mic.
Yeah, thanks, Anuj.
Hi.
So, is there any automated tools which we can make our code compliance to the principles or best practices?
I think I'm seeing a lot of AI startups coming up in these fields. If you write a PR, it all automatically reviews it for you and calls stuff out. But I think this is quite subjective. People, it's going to take some more time. But they are AI code reviewers, etc. They'll call out some things, but not everything.
Have you used anything?
Am I allowed to call company names out? Yeah, okay. So there's this tool called CodeAnt that I saw. I think they are kind of making strides in that. They are calling out dead code, unusable code, and patterns. We use this tool called Graphite to track all of our PRs and all of that. So it has its own kind of inbuilt reviewer that calls out some issues. But this is more like testing again. Like there's no one single tool that does everything. Maybe there are different tools that do small parts of this, like write tests for you, add automated tests for you, and all of that.
Yeah, thank you.
Yeah.
So just a general question. So these stuff that you mentioned, how are they different from the clean code practices? So you might have heard of the book Clean Code, and that's like pretty much in use by most companies. So
I'm not sure if it is, because I've mostly learned on the job. I didn't really like try and go through that, but I think most of it is probably what they also kind of recommend.
Yeah, so this book released in 2008, and even when I joined my company, the first thing they did was hand out this book for all the engineers to go through.
That's
so
nice,
that
yeah.
Like,
I think I started reading this book called Clean Code. I think that also kind of had similar these things, but this is mostly just practical. This is what I kind of found of sorts.
So have you used pre-commit hooks, and what your take on that? Because we configure linters and lock people not to.
Oh yeah, pre-commit hooks save lives and jobs. Because I think sometimes we just miss things and we just commit. I don't know, you made a lot of changes, but you forgot to save them and you're pushing them regardless. But pre-commit hooks definitely are lifesavers. I think they're a very good part of the automation. And tools in automation that you can have as a company.
And since you are allowed to say the names, so you are omitting the name of the website about design patterns. Is it Refactoring Guru?
Yeah, it's Refactoring Guru.
Just
yeah,
wanted to confirm.
yeah, it's really good.
We have time for one small question. Also, I'd request the audience to not move around when the Q&A is going on. Please settle down and maintain silence.
Like Coder and YouTuber like Primeagen, they are a little against on mocking in unit testing. So what is your stance on it?
Well, I'll have to watch those videos to understand why. I mean, they might have a point. I think mocking is, at least for me, it was just a difficult concept to understand in general when I was writing all these things. Okay, it seems like it wasn't just me, so I'm happy that I wasn't the only one who was confused. But I think unit tests definitely no. I think we definitely want a lot of unit tests. It just helps, especially when code bases start getting more and more complex. Yeah.
Thank you.
Thank you so much, everyone.